In this video, I'm going to explore the idea of sublimation using iodine as my example. Now, iodine is quite obviously a non-polar molecule, but it's solid at room temperature. That seems a bit strange because being non-polar and not that big, surely it should be a gas. Well, the reason that it's a solid at room temperature is the first thing we need to understand before we understand sublimation. Okay, so iodine is very far down group 17. It's got a very large electron cloud for a diatomic molecule, so one made up of only two atoms. Having a large electron cloud, the probability of temporary dipoles becomes quite large. So the distribution of these electrons in the electron cloud can vary at any one moment. So temporarily, let's say that they're closer to this iodine than to this iodine. That would mean that this side of the molecule would be slightly positive and this side would be slightly negative. So a temporary dipole has been created. Now, iodine having such a large electron cloud, the chance of this happening is a lot higher than, say, in bromine, which is much smaller, and therefore chlorine and fluorine. These two are gases at room temperature, and this one's a liquid that becomes a gas very easily. So these are all from group 17. They're the diatomic elements of the group 17s. Iodines of these four has got a much bigger electron cloud, so it's more likely to have temporary dipoles. In particular, these ones, the instantaneous dipoles. Now, when the iodine molecules get near another iodine molecule, then they can induce a dipole in the neighbouring one. So this will push electrons, this slightly negative charge will push these electrons that way, which will induce a dipole here. And likewise, that will induce one in a neighbouring molecule. This is slightly positive, so it will attract electrons this side in the electron cloud, creating a delta negative and therefore a delta positive. And if we can imagine this happening in 3 dimensions, then we can see how we start to form some intermolecular bonds between these non-polar molecules. Now, why would that happen with iodine? Well, having a larger molar mass, at room temperature, these particles are moving much more slowly than these particles as well. Larger mass, and if you think of kinetic energy, remember EK equals half mv squared. Well, if mass is much, much higher, for the same amount of energy, which is linked to our temperature, then they're not moving as fast, so they're more likely to get caught, as it were, and therefore these be induced. So iodine is a solid because of its large mass and its large electron cloud, therefore more instantaneous dipoles, more induced dipoles, and what it does is it creates a three-dimensional lattice of iodine that is an iodine crystal. Now, when I heat iodine, these will, of course, break because they're very weak. There may be lots of them, but they're very, very weak, and they start to break. When they do break, that extra energy, due to the increased temperature, the increased energy, doesn't just break the bonds. It makes the particles move faster. Because they're moving faster, even if they get these instantaneous dipoles, they're not getting close enough to other iodine molecules at this speed to induce dipoles and recreate this intermolecular force. A liquid requires forces to be able to be broken and made regularly so it can flow, so it's a fluid, but there's also still a relationship between the molecules. So for example, the permanent dipoles in water come and go, break, remake to allow water to flow. It's also when they make that we get our surface tension of water. Iodine can't do that. It's non-polar. Once we break these things, then they're broken. Because actually, as we do it, we speed these particles up too much as well. So, because it's only diatomic, it escapes. Now carbon dioxide, dry ice, is the same idea. Once we break the intermolecular bonds between dry ice particles, they have too much kinetic energy. They move away from each other too quickly because they're quite small molecules. Relatively speaking, when you think of things like wax or other solids that are non-polar. So sublimation occurs when we go directly from the solid state to the gas state, no liquid in between. It happens because when I add energy, what happens is that I break the bonds, not the iodine-iodine here, but the I2-I2 bonds, these green ones. But in doing so, we also increase the kinetic energy and therefore the speed of the particles, and so they can't reform bonds to therefore be liquid. They escape because there is no bonding between the particles. And this works for iodine, and it also works for dry ice, which is CO2. And here's my Lewis structure for that. Same idea, I can get instantaneous dipoles at a low enough temperature. I believe it's negative 44 degrees, don't quote me on that. Low enough temperature will slow those particles down enough that those instantaneous dipoles will induce ones in neighbouring particles and create a 3D structure. Heat it up, start breaking the intermolecular bonds, the particles move too fast and can't reform bonds, so therefore never go in the liquid phase under normal pressure.